Let f of z be z cubed minus 4z squared plus 9z take away 10. Show that z equals 2 is a root of f of z. So substitute in. F of 2 would be 2 cubed, which is 8. Take away 4 times 2 squared. 4 times 4 is 16. Plus 9 times 2. Take away 10. And that equals 0. And that means that z equals 2 is a root of f of z. We now want to solve f of z is 0. So what we want to do is factorize. So z cubed minus 4z squared plus 9z take away 10 is going to be z take away 2. And then we would have a quadratic factor. Well, because that's a single z cubed there, we must have a z squared. Because of the negative 10 here and the negative 2 here, we must have a plus 5. We might not be sure what the middle term is just yet. But then looking at z squared coefficients, we have negative 4 on the left. On the right, well, I've written a cube there where it should be a squared. We're going to have negative 2 plus a. So negative 2 plus a. And that means that a equals negative 2. And so we have z minus 2, z squared minus 2z plus 5 is equal to 0. Well, let's consider the quadratic bit. So z is going to be 2 plus or minus the square root of 4 take away 4 times 1 times 5 divided by 2. So that gives us 2 plus or minus the square root of negative 16 over 2, which is 2 plus or minus 4i over 2, which is 1 plus or minus 2i. So our final result is that we have 2 from there and from part 1 of the question. And then we have the 1 plus or minus 2i. So let's look at the next part of the question. Solve z to the 4 equals 8 root 3 minus 8i, giving all solutions in the form r cis theta, where our theta needs to be between negative pi and pi. So 8 root 3 minus 8i would be sort of down here, such that this is 8 root 3, this is 8. So that would give us, using Pythagoras' theorem, we would have 3 times 64 when we square that one, plus 64. So it's 256, square root that, and we get 16. And then the angle here would be pi by 6. So we can say that our z to the 4 is 16 cis negative pi by 6 plus 2n pi, where n is an integer. So z is going to be, well, the 4th root of 16, which is 2, and we divide the argument. So that's going to be negative pi on 24 plus n pi divided by 2. And now it's just a case of choosing the n's that give us the correct angles, or in the correct domain there. So if I take the n equal to negative 2, the angle in there is negative pi by 24, and we'd be taking away pi, which means that we would be taking away, going to make a correction to that. N equals negative 2 would be out of range because this angle is negative. So we want to take -1. The n's that we want here are going to be -1, 0, 1, and 2. So we'd be taking, if n is -1, we'd be taking away pi by 2, which is 12 pi by 24. So the first one here is going to be 2 cis -13 pi by 24. And then as we go forward each time, we're just going to be adding 12 pi by 24. So the next one will be 2 cis. Well, this is the n equals 0 situation, so that is just -pi by 24. And then the next one, we're going to add 12 pi by 24, so that will give me 11 pi by 24. And then we're going to add another 12 pi by 24, so that will be 2 cis 23 pi by 24. And now they are all nicely in the interval. So I couldn't have taken the n equals -2 as I first said. These ones are all in the right domain.